So here we have a couple of examples working with scientific notation and exponents, okay? So we're going to use the rules we've been learning to simplify these problems, but then making sure that they are in scientific notation. So I have number 1 started here already, and that's saying that this 3, right, this exponent 3 that is outside of this parenthesis, it is associated with both values in here, right, both bases, the base of 2 and the base of 10, okay? And when we have that exponent outside of parentheses, what we do is we multiply it by any exponents within the parentheses. Since 2, that would have an exponent of 1. So it would be 1 times 3, so that's how we got 2 to the 3rd power. And then we get 10 times 10, it's to the negative 3rd originally. Negative 3 times 3 is negative 9. Okay? Then we need to look at it and say, is this scientific notation? No, it is not. We need to do 2 to the 3rd power. Well, that is 8. And then we look and we say, is this in scientific notation? Well, first we can look at, well, this is 10, okay? Scientific notation is always 10 to some power, okay? So that's okay. And then here, this number in the front, it always has to be between 1 and 10, right? It could equal the number 1, but it could not equal the number 10, right? So sometimes you'll see it written out like this. Right? So this value here, that 8, does it make this inequality, this compound inequality, true? 1 is less than or equal to 8, that's true, which is less than 10, that's true. So that is in scientific notation. So that's how you do number 1. Now, you might also encounter when you have negative exponents, okay? And so, again, we take this and we say, well, negative 3 needs to go to this 2, all right? Negative 2 had 1 as its exponent before, right? That's what it would be. So it's going to become negative 3. Then it's going to be multiplied by 10. Negative 9 times negative 3, that's going to be positive 27. Okay? Now, this is not in scientific notation form. So if we remember that any base raised to a negative exponent could be written as a positive exponent like this, right? If it's in the numerator, it would go down to the denominator. Times 10 to the 27th power. But that's still not scientific notation form. So we can continue to simplify. 1/8 times 10 to the 27th power. Okay. But that's still not scientific notation because we want it to be, we need it in decimal form, and then we need the number to be between 1 and 10. Okay? So 1 divided by 8, I could turn it into a decimal. I could get this, 0.125 times by 10 to the 27th power. Is this in scientific notation? It's not yet, because this is below the number 1, right? It would not make that statement there true. So what we need to do is we need to move the decimal 1 place. We'd get 1.25 multiplied by 10, and this would be like saying, right, if we were just doing this problem, to turn that into scientific notation, it would be that, right? 0.125, right, would be turned into scientific notation like this. But then we need to remember we already have the base of 10 with some exponent, and we then combine and say, well, when we have the same bases, right, being multiplied with different exponents, we simply add those exponents. So we get 1.25 times 10, negative 1 plus 27. That's going to be 26. Now, some of these steps, if you have a calculator, okay, negative or 2 to the negative 3rd power, you could probably plug that in, and your calculator can be set up so that it'll solve out and get you this value right away. But I wanted to walk you through, how did I get to that number, right? We said 2 to the negative 3rd power. Well, that could be rewritten as 1 over 2 to the 3rd power. 2 to the 3rd power could simplify to 8, getting us to this. 1 divided by 8 is that decimal, right? Then we turn that decimal into scientific notation and combined it with what we already had with the base of 10. But again, the calculator could have helped you skip over these 2 steps, but I wanted to show you so that you can understand those. Good luck with your lesson.